thermal fluid sciences experts. This is Pro Ready Engineer.
Volume flow rate. Well, you guessed it right. Volume flow rate, if I tell you the volume is flowing at, 1,000 liter per minute, 3 gallons per minute, these numbers mean something for you. You see, we like volume flow rate. It expresses the volume moving per unit time. If I tell you your faucet at home is around 1.5 to 3 gallons a minute, what comes to your mind? Say, if I turn the faucet on, open all the way, get a gallon, and stop my stopwatch, I fill, empty, fill, I'll fill 1 to 3 gallons every minute, right? Engineers, they like things that make sense and that they can put to work. You see, when I tell you, for example, that your amount of water that you consume daily, every person needs 50 gallons. It's important for you because if you say, if I get 50 gallons a day, 50 gallons I need a day, then in a month I need a 1,500 gallon. Now you're going to go buy a tank she without even knowing. You now suddenly felt that you know the size of the tank you will buy to get you the water you need for a month, for example, right? So volume flow rate, we like it because it relates to the volume where the thing is contained and I am using it, if that makes sense. Now, for example, this is why engineers came up with the miles per gallon. Think about that. Your car, you say miles per gallon. How many miles per gallon? And everybody here is relating to it really quick. So you say, I get 20 miles a gallon. 1 gallon gets me 20 miles. So 10 gallons. And you can estimate that, okay, I need to refuel once a week. Or I'm driving a car that is, burns 7 gallons per mile. So I need to fuel every 3 days or 4 days, something like that, right? Volume flow rate. We tend to use CFM, right? CFM is cubic feet per minute for air. We like that number for air. You see, for water, we use gallons a minute. For the fire hydrant, gallons a minute. You know that fire hydrant where they use if God forbid, there's a fire, that can put about, 500, 600, 700, 1,000 gallons a minute. Just think about that. Tremendous amount of water from a hydrant. Now, it happens that when we deal with air, we like CFM. Why do we like CFM? Why do we like cubic feet per minute? Why do we like cubic feet every minute? Think about it. Engineers use numbers that make sense. You see, you're going to buy an HVAC system for your house. And let's say that your house is 26,000 feet cubed. You know the volume. Your house has a volume. And there's the air sitting in this volume and it's very hot. Temperature is 80 degrees. You turn the AC on. That AC is going to take that air, cool it down and pump it back. If your HVAC is 1,000 feet cubed per minute, 1,000 CFM, your HVAC pumps 1,000 cubic feet every minute. How long does it take your AC to pull all the air in your home and pump it back cold? That's a very important, number to build a feel for. And in this case, that would be about, 16 minutes. So If that's your system, if that's your home, you turn the AC on, you're probably going to wait, let's say temperature 80 degree. You're going to wait minutes, 10, 15, 16, until that. So we like it because it expresses and relates to what we are trying to achieve. The amount of air we are moving per minute, in this case, relates to that. Right, good. You see a dam, a water dam here. These water dams, tremendous. You can see videos on YouTube. That's a 10,000 meter cubed per second. Now think about that number for a second. It's humongous. You know what is 10,000 meter cube? You know what is 1 meter cubed per second? 1 meter, that's about 1 meter. Like from the tip of your finger to here, it's about here, like 1 meter. So 1 by 1 by 1, this is called 1 meter cubed. If I fill 10,000 of that in 1 second, what is the amount of water that we have? It's just. Do you think a human being can survive this water falling on the person? Right? So you build a feel. You have a feel for what does the number mean, the magnitude, and so on. This volume flow rate is area times velocity. Area times velocity. Mass flow rate is rho AV. Volume flow rate is just AV. So the relationship between m dot and volume flow rate, m dot, rho times Q. That's the relationship right here. M dot is rho times Q. This is how you transfer it from being the mass you are pumping to the volume you are pumping. Right? Okay. How do we measure it? Well, positive displacement meters, like gear pumps and so on, they meter the amount, the volume that is being pumped. Rotometers, like this device is a rotometer, right? Turbine flow meters, ultrasound, differential, all these can actually get you a volume flow rate estimate, if you will. And now you know this is very common, though simple, very common, this rotometer for HVAC and so on, if you will.